So we're looking at page 4 of the unit packet, or the course packet. And we're tackling, really it's the same data set as the previous page, except now we're looking to find the median of the data set. Okay, it can be a little trickier when you're dealing with a frequency table. Okay, and that's because the number 1 occurs 10 times. And just for this one time, I'm gonna write the number 1 out 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 2 occurs 3 times, so 2, 2, 2. The 3 occurs once. The 4 occurs 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And the 5 occurs 5 times. All right, so what we can do here is reorganize this so that it's all in a straight line, horizontal. I'm gonna just grab these two together. You might see where I'm going with this. And if you do, you might see that there's a pretty significant flaw with this approach. All right, but let's see if we can figure that out together. All right, so if I want to find the median, all I would have to do, that's a sarcastic all, is count to the middle. Doop. Doop. Then an hour later, of course, we get our answer. All right, so I'm just kind of working my way in, working my way down the line. And if you lose your concentration at any point, it's all over and you fail. He said with an inappropriate amount of glee. No, that's not the idea. We don't want that to happen, so we need a better way, because this way is pretty brutal. And even for a relatively small data set, it's still problematic at best. All right, because I finally, at long last, got to that middle value, which is the number 3. And so, yeah, okay, fine, I got the median of 3. That's wonderful. That's wonderful. There's a couple other ways that we can do it. One way would be to kind of count in chunks, which is to say, all right, instead of going one at a time, what if I went 5 at a time? Like, for example, I got 5 5s over here. Let me cancel those with 5 of the 1s, all right? In the original diagram, that would be the same as saying, let's get rid of 1, 2, 3, 4, 5 of the 1s with all 5 of the 5s. My strike through is a little off there. All right. So then I could just do that again and say, okay, well, I got how many? Let's take a look. Let me do a different color here. I got 1, 2, 3, 4, 5, 6, 7, 8 4s. 1, 2, 3, 4, 5, 6, 7, 8 4s. And let's see if I can cancel that with 8 numbers on the other side. 6, 7, 8. And that works out. We get an even amount of cancellations on one side as we do on the other. All right, so that would be the same as saying, okay, we're wiping all these out. All right, so let me get another strike through going. So all of these with all of these. And what you'd be left with is just a single value in the middle, that number 3. All right, so you could do them in bunches, is what I'm saying. Even that technique, which is actually the technique I have written out here, is still cumbersome. All right. Another technique, one that might be a little bit more user-friendly, is the idea that the median is equal to the 50th percentile. Okay, so it's the 50th percentile. So if we know the total number of values in the set, I'm going to create a little space here. I'm going to smidge this down a little bit. And just get the sum of this frequency column. Because the frequency tells you how many times these numbers occur. So the 1 occurs 10 times, the 2 occurs 3 times, and so on. That means that whatever the sum of the frequency is the total number of values in the set. So 13, 14, 22, 27 values. So what I can do is take that 27 and multiply it by 0.5. Or 0.50. All right, get a different highlight color here. I'm going to go with a lightish pink here for those keeping score at home. More of a purple pink. All right. But if I multiply those numbers, let me get rid of this stuff. Different class. Well, same class, different topic. 27 times 0.5. That gives me 13.5. All right. So that kind of leads us to a little bit of a conundrum, I suppose. It's like, how do you get the 13.5 value? All right. That doesn't seem to play out too well. It doesn't seem to make much sense. In fact, if I go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a half. That's pretty close to what the median ought to be. It's just not quite there. All right. So, but the rounded value would be there. All right. So if we round this, that gives us the locator for the median. So 14th value. So then when I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14th value would be your median. All right. So that's great if the data is in increasing order. All right. So what if it's in the table? Okay. I got 10 values here plus 3. All right. So we're up to 13. I got 10 after the first setting. Setting. Geez, I don't even know what I just said. 10 after the first category, or the first class, the first group. Now I'm up to 13. Once I get that next category involved, I'm up to the 14th value. Remember, the frequency column is the number of times that value occurs. The number that I'm interested in is the corresponding X value. All right, and so that would give you your median. All right, so you can kind of look at it that way. So that's a possibility. All right, any of those ways are an appropriate by hand, quote unquote, by hand approach to solve for the median. We do run into another issue though. What if you don't get a decimal value? All right, when you do your multiplication, if the result is a whole number that we call, I'm just going to move this over because I misjudged where that should go. We'll call it M. We'll call it M. Whole number M. M and M plus 1 give the location of the median. All right, so that's the quirky part of this whole thing. All right, it's possible that you could use this other technique and get, a weirder answer. All right, so what I'll do is I'll just throw a quick side example here. Find the median, and let's say we have the column X, 5, 11, 13, 15. With frequencies 2, 12, 10, and 8. All right, I just chose all even numbers, so I would know that my frequency column would be guaranteed to be an even number. All right. So I add up my frequency column. 18, So 18, 32. So what we do is we take that 32, multiply it by 0.5, or 0.50. Again, that 0.50 comes from the fact that it's 50%. If I wanted to find the 70th percentile, I would just do the same thing, but multiply by 0.7. All right, so that's going to give me a 16. So that tells us that the 16th and 17th values make up the median. All right, so we go into the table and we take a look and we say, all right, after our first category, we have two values. All right, so two values. All right, both of them are 5s. 5 and 5. Frequency of 2 means the 5 occurs twice. The 11 occurs 12 times, so we're up to 14 values. Then we gain 10 more values, so we're getting it from all of these frequency counts. So now we're up to 24. I don't know where the 16th and 17th values are, but wherever they are, they have to be in this category here. Because the first and second values are 5s. The second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, and 15th values, and 16th values, are going to be the 11. All right, and then once we get into that next category, the 13s, there's going to be 10 more of those. So the 17th, 18th, 19th, 20, 21, 22, 23, 24, 25, and 26 values. All right, the 16th and 17th will be one of those values, one of those 13s. All right, so it's going to be 13 and 13. If you were to list out all these numbers, you'd see 13 and 13 make up the median, average them together, and you get the median of 13. All right, so apologize for the mess here, but I figured it was worth it to do a side example just to talk about that other weird occurrence, just because I neglected to put that in the notes. So this is my median for that side example. All right, I'm going to kind of smidge this down so I don't steal room from other things. Let me just kind of cordon it off here. All right. So that was a little tricky. There is a calculator shortcut, but we'll cross that bridge in a little bit. The mode's actually a whole lot easier. You're looking for the number that occurs most frequently. The mode in this example is equal to 1. 1 occurs 10 times. Everything else occurs less than 10 times. 2 occurs 3 times, 3 occurs once, 4 occurs 8 times, 5 occurs 5 times. Nothing occurs as many times as the 1 occurs. All right. And while we're here, my little side example, again, the mode, the most common value, the one that occurs most, the mode would be the number 11. You know, my original example didn't ask for that, but it doesn't really take much to change that. Find the median and the mode. Oh, look at that. New problem. All right. The last case is a little bit of an extension on this. It says a little notation. If the class interval is a range, you see how it goes from 10 to 19, then 20 to 29, 30 to 39, and so on. If it's a range, we use the class midpoint. All right, so for example, the class midpoint here would be 10, and I'll just zoom in, 10 plus 19 over 2. So it's a halfway point between the 10 and the 19. Excuse me. Which is going to be 14.5. All right, we would do the same thing with the 20 and the 29, which would give us a 24.5. Once you realize the trend is that it's increasing by tens every step of the way, 34.5, 44.5, 54.5. All right, so what we want to do now is find the mean, the median, and the mode using this information. All right, so these are my x values. These are my frequency values. Now, on the previous page, we learned a table approach for figuring this out, but we want to use Desmos to kind of structure that table approach so that we can use it over and over again, all right? But to find the mean, sorry, I got a frog in my throat today for some reason. The mean is going to involve finding the product of x and f. So I got to multiply across and then add up the results. All right, easier said than done, especially when the numbers aren't so nice. So what we'll do is we'll use a table in Desmos to help us do that. All right, so what I'm going to do is I'm going to hit that little plus sign in the Desmos, desmos.com, go to Graphing Calculator. I'm going to tap on that little plus sign and select table. All right, so all these values here are going to go into x1, and all these values here are going to go into y1. All right, that's just the way Desmos is designed. All right, so it's kind of like the sort of thing we have to live with. Otherwise, you got to pay $120 for a graphic calculator. So here we are. All right, so 14.5 is my first value, 24.5 is my second value. It recognizes the trend that I'm increasing by 10, so I just hit enter, enter, until I get to the last value that I want. And I type in my 51, my 13, my 22, my 4, and my 92. All right. If you're familiar with Excel, then you know that you can operate on columns. You know, you can work columns against other columns through different operations, addition, subtraction, multiplication, so on. So if I want to multiply x by f, what I'm really going to be doing in Desmos is taking x1 and multiplying it by y1. So I'm going to tap into the column heading for the third column and just type in x. You see it's hidden because I'm using the touchscreen. It's a little better on a laptop, desktop, whatever. But you can see it hidden in the background there. It says x, type in the 1. It knows that it ought to be a subscript. And then type in y1. And then hit enter if you want. And it'll give you the product of all those values. So 739.5, 318.5, 759, 178, 5014. Now to find the mean, normally the formula is the sum of x multiplied by f over n. All right. Now n is the number of values in the set. So I'm going to do a quick erase here and say, well, n really is going to be the sum of whatever's in the f column. All right, but Desmos understands this a little differently. All right, so what you're going to do is you're going to use the total function. All right, so this is all for Desmos. And the good thing about creating an appropriate Desmos is that you can save your work and use it again and again. All right, so it's not a one and done. So you don't have to memorize these steps because you create it the one time, you save it, and then you use it again. All right, so we're going to find the total of x1 times y1, and then the total of just y1. And that's going to give us our mean. All right, so, how do we do that? Well, we tap into a new field, fraction. Under functions, under stats, you see an option for total, all right? But let's say you don't remember that. Go into ABC and type in total. Once it recognizes it as a Desmos command, it goes from italics to ordinary font, open paren, x1, y1, and then again total. This time I'll do it through the function, just tap in total. You see it looks exactly the same. This time it's just y1. And what it has done for me is it computed the mean, all right? So 38.511. All right, now the issue that you're gonna run into is really more of a confusion thing than anything else, is that you go in here and you see, you tap on stats, we're going for total, you see that good looking mean right there. It says MEAN, mean. Why aren't we using that? That only works for one column data sets, right? This is two columns, right? This is a frequency table. Desmos doesn't have the functionality to handle frequency tables, so we have to work around, all right? So there's that. But we'll save all this stuff anyway, so like I said, you can use it again and again. And in fact, good idea to pop in a little note saying that this is a sample mean. Just kind of slide it up. Oop, yeah, there it goes. A little bit more aggressive than I wanted, but there we go. That's our sample mean. You'll have to know that it's X bar because there's no symbolic notation for X bar, but you'll make a note of that somewhere and remind yourself. All right. So this is the rule here, and this is how Desmos knows it. All right. Now for the median and the mode, well, there's really no mode per se. What we would say is that there's a modal interval. I'll come back to the median in a second. Modal interval. It's kind of a tricky concept. A modal interval is the interval that contains the most information, which is 50 to 59. You see that 92 occurs more than anything else. And that's because we don't know what the values are. It is possible that all the values in the 50 to 59 range are evenly distributed. There's 10 values between 50 and 59. Let's say most of them are 9s, and you have, let's see, 9, 10, and one of them's an 11, right? I think that works. So 9 9s and 1 11. That gets you to 92. Right? So the most values that you have in the 50 to 59 range would be 11. Whereas in the 10 to 19 range, maybe all 51 values are 19. In which case, 19 would be your mode, but we would have no way of knowing that because they didn't give us that information. So the best we can come up with is the modal interval. All right? When it comes to the median, we're going to use the same technique that we did before. We're going to add up our frequency column. To do that, we could just use the total function again, or we could just add them up. Sometimes you don't want to get too fancy with this stuff. But there's 182 values. All right? So n is equal to 182 values. So 182 times 0.5, 0 if you want. I'll just clear this out, we don't need it anymore. You could actually just multiply that by 0.5 if you want, but 182 times 0.5, 91. So I'm looking for the 91st and 92nd values. Oops. All right. So you can count from bottom to top or top to bottom, because if the data is organized, you're still working your way to the middle. So after my first interval, I have 51 values. After my second interval, I've gained an additional 13, so now I'm up to 64. 86, after I got 22 more. After I gained 4 more, I'm up to 90. So my first 90 values, 1 through 90, or in this case, like starting with the number 10 and then 90 values later, are already accounted for. In this interval, we'd have the 91st, 92nd, 93rd, and so on, all the way up to the 182nd value, right? But that's not as important as knowing that the values between the 91st and the 182nd value are in this interval. All right, I'm looking for the 91st and 92nd. Both values are in this interval. Doesn't matter what they are. Let's say one of them is a 50 and the other is a 52. Average them together, whatever number you get is still going to be in that interval. I don't know what the number is going to be. All I can do is state that the median interval is going to be also 50 to 59. A little glitch there in the software. All right, so we can get an approximation of the median of the mean, but then we're really getting approximations of the median and the mode. All right, we call it the median interval and the modal interval. And that brings us to the end of page 4.